Hello, welcome to our unit on conditional probability. We've learned a little bit about this before. This notation, probability A, vertical line B, means it's the probability that A occurs given the fact that B has occurred. So given that is what that vertical line really means. Now, we're going to, this probably doesn't make a lot of sense right now, but as we get through some problems, hopefully you'll understand. So first off, the probability that an Irondale student wears maroon is 0.48, and the probability that the Irondale student wears gold is 0.57. Now these are dependent events, so knowing that someone's wearing maroon gives them a higher chance that they're wearing gold, because those are school colors, and generally people wear them together. So these are dependent events where the probability that an Irondale student is wearing both maroon and gold is 0.38. So if I want to make a tree diagram out of this, there's a lot of people that love tree diagrams. And I like tree diagrams in some situations. So this is maroon, and let's say not maroon. And then we have gold, and then we have not gold. So the probability that we're maroon is 0.48. So the probability that they're not wearing maroon is 0.52. Now, the probability that they wear gold is this one and this one together. So we can't fill in this number quite yet. But we know that the probability that they're wearing maroon and gold, so this and this together, will be 0.38. So if I want to find out just this probability, I know 0.48 times some number equals 0.38. So if I bring up my calculator from my computer, if I type in 0.38 divided by 0.48, it will say 0.7916. Let's just say this is 0.79. So if there's a 0.79 chance that they're wearing gold, that means that there's a 0.21 chance that they're not wearing gold. So I can find out this probability by taking 0.48 times 0.21, and that's about 10%, so 0.10. Now here we need to think about this. These two, the two golds have to add up to 57%. So if I take this, subtract it from 0.57, I'll get 0.19. So now if I want to find the probability that we're in gold given the fact that they're not wearing maroon, I take 0.19 divided by 0.52, and that's about 0.365, so let's say 0.37. And if that's 0.37, 1 minus that will be down here, so that would be 0.63. So to find out that we're wearing neither, what we'll have to do is 0.52 times 0.63, which is 0.33. Now, we, we have all of these probabilities. So if we add all of these probabilities up, they should equal 1. So that's 17 plus 3, that's 0. Carry the 1, that's 4, 5, 6, 7, 8, 9, 10. Oh, I should have carried a 2 over. Now it's 10. Way to go, mass. Alright, it works. Adds up to 1. Alright, now let's do this with a Venn diagram. You can see it was a little tricky with the tree diagram. So to do it with a Venn diagram, what we'll do is create two circles, where this circle over here is the maroon, and the other circle will be the gold. And the probability that they're wearing both is 0.38. Maybe it would be easier to just do this. So both is right in the middle, so that's 0.38. So if the whole maroon circle is 0.48, then if I put 0.10 over here, these two would add up to 0.48. Now, if this whole circle adds up to 0.57, over here would be 0.19. Now, if I draw my box around the outside, this is my entire sample space. If I add these up, subtract from 1, I should get 0.33. Now, notice how these give you all of the answers that are over here. But we do it in Venn diagram, which I think is a little bit easier than a tree diagram. But some people just love this tree diagram, so if you love it and it works great for you, go right ahead and use it. Now, we have to look at certain probabilities. I want to find the probability that someone's wearing maroon, given the fact that they're wearing gold. So this is my new sample space. Sample has M. So I want to reduce everything on this Venn diagram to just the people wearing gold. So just here adds up to 0.57. So that's going to be my denominator over here, 0.57. So out of this group, what's the probability that they wear maroon? Well, it's 0.38 out of the whole group. So 0.38 over 0.57 is the probability that someone's wearing maroon, given the fact that they're wearing gold. So if I put this in my calculator, 0.38 divided by 0.57, we get 0.6 repeating. So there's about a 2/3 chance that they're wearing maroon, given the fact that they're wearing gold. Now let's switch that around. What's the probability that they're wearing gold, given the fact that they're wearing maroon? So now maroon is my sample space. So if I come back here, this is my sample space, which is 0.48. Now how many people are wearing gold out of that? Well, that's 0.38 out of the 0.48. So 0.38 out of 0.48. That's 79%. So about 0.79 is this probability. Hopefully you're starting to understand how this conditional probability works. Now here's kind of a tricky problem. Common sources of caffeine are coffee, tea, and cola. Suppose that 55% of adults drink coffee, 25% drink tea, 45% drink cola, 15% drink both coffee and tea, 5% drink all three beverages, and 25% drink both coffee and cola, and 5% drink only tea. Let's draw a Venn diagram to describe the situation. But to do so, we need 3 separate circles. Now the first thing we can put on is 5% drink all 3 beverages. So that's 0.05. Now we know, say if this is coffee, there's not 3 F's in coffee. Coffee will have to add up to 55%. Tea will equal 0.25. And cola will equal 0.45. 15% drink both coffee and tea. Coffee and tea will be this entire football-shaped thing here. Now 15% lies here. No, 5% lies here, so 0.10 will have to lie in that section. So we have all of these taken care of. Now 25% drink both coffee and cola. So coffee and cola, that's this football shape here. If that's 25%, then 0.2 is going to be in that section. Now it says only 5% drink only tea. So that's 5% over here. They only drink tea. So now let's find all of the other probabilities. Now, t adds up to 0.25, and if I look at my t-circle, so far we have it adding up to 0.2. So this little part has to add up to, it has to be 0.05, so it all adds up to 0.25. Next, these three sections add up to 0.3, so it here has to add up, it has to be 0.15, so the whole circle adds up to 0.45. Likewise, in this section, this adds up to 35%, so we need a 0.2 out here. So now we have to add up all of these numbers and subtract from 1 to see what's on the outside, people who don't drink any of it. So this is 0.2, 3, 4, 5, 6, 7, 8. So 1 minus 0.8 is going to be 0.2. So there's going to be 20% of the population who drink none of these three. So what's the probability of only cola? Only cola would just be 15%. If I can write it, saying it's easier than writing it apparently. What's the probability of cola given the fact that they drink tea? So if I look down here, probability of cola given the fact that they drink tea. So out of the circle, which is 0.25, how much of this circle drinks cola? Well, it's these two parts. So that'll add up to 0.1. So 0.1 over 0.25 should be 0.4. What's the probability they drink coffee given the fact that they drink cola? Probability of coffee given the fact that they drink cola. So cola is 0.45, so let's start there, 0.45. And what's the probability of coffee? Well, it's 20 and 5, so that's 25%. Now I can't do this in my head, so we have to 0.25 divided by 0.45, and that answer would be 0.5 repeating. So this answer is 0.5 repeating. Alright, hopefully you're getting the hang of this a little bit. Now let's see if we can do it from a table. Now in this situation, what's the probability that a randomly chosen event here is a liberal arts? Comes from a liberal arts course. This is a distribution of grades A, B, and C in different categories: liberal arts classes, engineering, physical science, and health and human services. There's a total of 10,000 grades being looked at. So the probability that it's liberal arts will be 6,300 out of 10,000, which is just 0.63. The probability that they got an A, given the fact that it's a liberal arts course, well, this is our new sample size, or sample space. Oop, I can't draw a circle apparently. Let's try it again. This right here is our new sample space. So 6,300 is the total amount of people. So the probability they got an A out of those is 2,142. So if I take out my calculator, 2,142 divided by 6,300, that's 0.34. What's the probability that it was from health and human services given the fact that it's an A? So we can reduce our sample size space to just the A. That's 3,392. And what's the probability it's from health and human services? That's 882. So I take 882 divided by 3,392. It's 26%. All right, now there is a worksheet for tonight. Good luck.